This is a question that wasn't done particularly well the previous year, and it was something that was obviously assessed again last year. What we're given here is they need to make reference to task E, which is at one end of the dummy link, and also they've got to look at what's happening with tasks C and D. So in relation to task E, it needed both tasks A and B to be completed, whereas task C and D only needed task B, okay? That was something that was highlighted in the examiner's comments from 2022, and I think it was highlighted again this year. Again, something that students weren't doing particularly well. Any questions? Yep. Okay. Again, a relatively straightforward forward and backward scan to complete. We tended to see that most of the errors were coming around either this position here or down in this position here. So most students were okay. Probably more so with the backward scan than forward scan in this case. We tended to see more mistakes in the forward scan, which is probably unusual. It tends to be the other way around. Minimum completion time, so whatever they had for their final answer was what we're looking for there in terms of their time. Okay. Question 2. So question 2 is a question on normal distribution. You can see here that the standard deviation for this example is 1.1, so we're looking for between 3.4 and 4.5, so it's really just one standard deviation. So it's one standard deviation away from the mean, so we're happy to accept 0.34 as the probability. They could also have done NCD calculation with that one, and I'm just giving an example of how you might have done that with NCD, but really we're just looking for the 0.34 in terms of the probability there. With the next part, in 1 month we had 5,500 people attend the emergency department. How many would be expected to wait more than 2 hours? So the lower bound there we had 2, upper bound obviously is unknown. So we're looking at the probability of 0.898 and then obviously multiplying that by the number of people. In this type of question, because it's looking at people, we would expect students to give a whole number answer, because you obviously can't get a fraction of a person. Any questions about anything so far? Yeah.
When it's been asked during the last with question lines, if you gave 34% and 30 worked like 1 minute 3 hour, do you just stop with a month that to use? Say, percentage.
If it's a percentage of probability, you can give it as a decimal or percentage as a fraction, so we'd be happy to accept that. Okay, any other questions at this stage?
Yeah. Sure.
Yep.
I've only done 2 of perplexing years. What's the expectation, say, as far as significant figures that did?
What I'd encourage you to do is have a look at the examination report from last year. Okay, it was something that was talked about. Generally, giving more is better than not giving enough. So if you gave like 0.3 for the answer to part A, that wouldn't be enough. 0.341, 0.34, that would be considered enough. So giving more is better than not giving enough. Does that make sense? Yes.
Yeah, they do. Basically, because it's a question that we're dealing with people and you can't have part of a person, if they don't give a whole number, then they can only get a maximum of 1 out of 2. Just for those that are walking in, there isn't actually any more copies of the exam. So I know you're walking around to try and find them, but that's all we were given. And once they were gone, they were gone. Sorry. We'll try and get Massa to send out some more copies.
Okay. Part C looks at, we're looking at finding a k-value essentially. So we're doing an inverse normal calculation. What's important here is the positioning of the tail. So we've got the tail on the right-hand side because we're looking at that upper proportion. And we were happy to accept approximately the 4 hours in this case. I think the answer your calculator will give you is the 4.0087. But approximately 4 hours would be okay there. If a student does the tail in the wrong direction, they would lose a mark there, so they can still get a follow through for having tail in the wrong direction. With the next question, we were asking to state if a claim is supported. So it said Hospital B claims that 25% of non-critical patients will be attended within 1.5 hours. So students could either tackle it from the 25% angle, or they could tackle it from the 1.5 hours. They needed to show one of these two calculations, and then they would need to give a statement to say whether or not the claim was supported based on what their calculation showed. So if they just said the claim supported, but without showing any supporting calculations, then it isn't possible to get the 2 marks there. They had to actually show some evidence of working to support that. But they could have tackled it in one of 2 ways there. Okay. Next one is, we've seen quite a lot of variation in these types of questions over the years with the various nested normal distribution curves. So what we're looking for, we've obviously been given information about Hospital A and Hospital B, and Hospital C has now been included, and we're looking at, can they pull out the correct information about the mean and the correct information about the standard deviation. So we know from Hospital B that it had a mean of 2.1. So Hospital C is at that same point. And we knew from Hospital A its standard deviation was 1.1. And because we've got that same height on the curve there, we can see that that's going to have the same standard deviation markers. So just a simple tick box for that. Part F, I might just move that in just a bit. Sorry. In Part F, we're asking, is it statistically possible for a non-critical patient to be attended in less than 0 hours of waiting time? So that comes about from what's happening down at this end of the normal distribution for Hospital C. And really, waiting time can't be negative. You can't have negative time. So that's something along those lines is what we were looking for from students. Any questions about anything there in question 2? Okay. Question 3 is the first of our finance questions. So we have information about an interest-only loan and a sinking fund. So we've got 2 options. We've got option A, which is the first part of the question, and option B is going to have a look at something else there. So if we look at what's happening, it's asking us to calculate the yearly interest payment on the interest-only loan. We've obviously got some dot point information there in the question, so it's can the students pull out the correct information from that to work out what their annual interest payment is going to be. Common mistakes there is finding what the total interest would be. That's obviously not asked for in that part. Or I think they were making, that was probably the most common mistake that people were making in that part. So some evidence of calculation there was good. In part B, the quarterly repayments that the club must make to the sinking fund. Just a standard compound interest question. Most common mistake here is the confusion of PV and FV. So students thinking that the sinking fund is a loan and not an investment. And that's something that, again, we've seen quite a lot through the years, and it's something to really emphasize with students. And with this one, somebody was asking about rounding earlier. Anytime we're dealing with finance, we're looking for correct to 2 decimal places because we're obviously looking at cents. Want to add to that?
Well, I'll add to that. When we're marketing, like often when you've got situations in finance, everyone can round slightly differently at times. So we're expecting the kids to put 2 decimal places, but we're not really focused on those digits. Often we're focused on the 2643, or in the next question, the 136258. Like we're sort of, if it's close to that, then we know they're on the right track. It's often that they might have rounded, say, the number before 2643.1 rather than 0.09. And so that's gonna mean that next answer is going to be slightly different, but that's okay. It's about the process and the fact that they've got basically to that answer.
Yeah, and we've obviously got limited marks that we can award, so we're looking at really the process and what they've come up with. In terms of the next part, we're looking at showing that the cost is approximately 136,000. So we're looking for, obviously, using part A with the interest, multiplying that by the number of years, and the end value for the sinking fund, multiplying that by our PMT value. Based on that, you're going to get something close to the 136,258.88 in this case. As we've just said, you might have your cents slightly different there based on how you've rounded, but students would have to show process for that. In this question, we give them an approximate value so that they can use that information later on in the question if they require that. Okay, so sorry, yep.
If people got a more accurate answer, are you expected to be using that, or would you not go use it?
They can actually use either. It doesn't actually matter. So it's allowing kids that can't get an answer to get back into the question, so that therefore they can keep going. But those kids have got the answer, they can use either. So it's up to them.
Yeah, and that's something that's been specifically addressed in the subject advice this year. You'll see it multiple times, especially in the finance section, where we do that, show that. If they can't get that answer, it still allows them access to the question so they can come back in. In terms of marking, we mark based on the show that answer and based on what the calculation was. So in some cases, like so when we get to the offset question, it can get quite complex. In terms of part C, the reason why that amount would be less is because you're generating or you're earning interest in the sinking fund. So you're not actually putting that in, it's generated in that investment. Part B looks at a reducing balance loan for 8 years, and we were looking to calculate a comparison rate on that. Probably a more straightforward comparison rate question than we've had in recent years because we've only got the $25 monthly charge there. There's no upfront fee, so it does make it slightly more straightforward. But what we're looking for here is students to calculate that initial PMT value based on the 95,000 and then add on that $25 charge per month and use that information to then calculate what the comparison rate would be. So that's the 3 parts to the question, and that's essentially where your marks are coming from in that section. The cost of the loan in D part 2, they have to use the 1261.90 for that because that monthly charge is applied. So if they hadn't used that, if they'd used this figure here, then they wouldn't be able to get that mark. Okay, so the knowledge of that's part of the cost. So we need to be looking at including that within that costing there. Okay, next one's looking at suggest one reason why the club might not choose the cheaper option. They could have got taxation benefits from the interest-only loan sinking fund option. They might have a better relationship with the credit union than what they did with the bank, so getting access to funds was easier. Quarterly repayments might work better for them than monthly repayments if it's a sporting club. So that was just a selection of things that were acceptable answers in that case. Any questions there? Okay. Last part of this question looks at inflation. So there's obviously a number of ways you can calculate. You can do that on the graphics calculator using the TVM mode, or you can do it using this exponential equation style section. But we're just looking at a simple inflation calculation there. And then one limitation of waiting 8 years. So they might lose members to rival clubs if their facilities aren't up to scratch. And it's going to probably cost a lot more moving forward because cost of materials will be a lot more expensive. This section was actually answered really quite well. And I'm not sure if all the news about inflation over the last year, how students have actually been listening to what's going on with that. But it did seem to be pretty well understood. Any questions there? Okay. Question 4 is the first of our statistics questions. So it's looking at a breeding program for long-footed potoroos. We've got a 5-year breeding program, so we can see we've got 6 monthly data about numbers. Students obviously needed to put that into the graphics calculator and tell us what the R value was. Again, going back to rounding, 3 decimal places, 2 decimal places, that was okay. If they'd rounded that to 1, that obviously wasn't, because that would indicate there's a perfect relationship there. State why it would be considered appropriate to make predictions. We've got, so this is kind of a different way of asking the same kind of question that has been asked a number of times throughout the years, when you're maybe asked to look at what, find an R-squared value and interpret it. So it's just asked in a slightly different way, but essentially looking for the same stuff. We've got a very strong positive relationship that exists between the variables. So it's obviously okay to use that. I think in the subject outline, it talks about that value being greater than 0.84 from memory. Can't remember. So it's around about there, so it's greater than that, then we can apply a regression to it. We then give them a choice of what their line of best fit is going to be. And we've obviously given them the variables there. So they've already put their information into the calculator to get their R value, so it should be relatively straightforward to select the model. I think there you can see we had the A and B value reverse round, and I think that might have been the exponential model. So there's a few things in there that obviously were set up in a linear format. With this one, complete the statement. For every additional month in the breeding program, the number of potoroos they needed to get both of these things. So it was going to be an increase because we've obviously got that positive R value, but we've got a positive T value as well here, where T is essentially the gradient. And we're going up by 2.01. I think we accepted 2, so going up by 2. But it was definitely an increase and going up by 2 in this case. And both needed to be correct there to get the mark. Next section is using the equation that they've got. So they can do this on the graphics calculator, or they can actually in graph mode, or they can just substitute in the values. It gives you 109.7 months or 110 if you're rounding that to a whole number of months. But that was just substitution using the graph mode in your graphics calculator. Any questions about that page there? Okay. Next page, we're now looking past the breeding program, and the potoroos have been released into their natural habitat, and we're looking at how the numbers kind of progress over the next 4.5 years. There's an outlier, so the students have to identify where that outlier lies. So they've got various different options, but this one we're obviously seeing it's increasing, and then we've got a drop here, and then we're seeing it increasing again. So that would be our outlier value there. If students select the wrong outlier, or if we go back to what we had here, if they'd selected the wrong model, then we obviously follow through with marking in both this section and that section based on the incorrect model there. But then if they've selected the wrong outlier here, they're obviously going to get a different model here, and there's follow through based on that as well. So they're not penalised. They're penalised by not selecting the correct outlier, but that's the only place they would be penalised if they've done the correct process moving forward in the question. The key bit here was using correct variables. So they obviously had to be looking at what's happening up in the table there. The variables have changed from what they had in the original section. So here we've got M and N, whereas previously we had N and T. So N for number of potteroos is obviously the same, but we've changed the variable from the breeding program to natural habitat. In this case, again, getting back to the question on rounding, so I think looking at what we had in the original part of the question, sorry, I'm just scrolling. If we look at what we've got here, that gives you a good guide for rounding there, but we've got essentially 3 significant figures there. We've done a little bit more. If you had the 195 there, that was obviously going to be okay. But we were looking for essentially the correct variables and students to be close to what we had with those values there. Do you want to add anything to that?
That's good.
Okay. And again, just applying that same process. Again, we've got the new model, so just a substitution in to find your number of months. And then in the final part, this wasn't answered very well at all, okay? And the reason why this wasn't answered very well was because what we got comparisons of was the 39 months here and the 110. So people were talking about a difference of, I think it was around about 71, but they hadn't factored in the original 60 months, okay? So they had to look at the 60 months, add on that 39, and compare that 99 to the 110 that they started with. So that was done pretty poorly. Students were still able to get the second mark from doing the comparison, but actually working out the times wasn't done very well. Do you want to add anything?
Yeah, there was certainly lots of kids that really only got 1 out of 2 in this spot. They really forgot about that extra 60 months. It was probably rare without a student that actually added on that 60-month time.
Yep. Does anybody want to ask anything about this question? Yes.
How many months that years, I guess, on another have to write the breast just see it's wide games. That's
Yeah.
Yeah, that is not.
So as long as they would only lose 1 mark if they had the correct numbers in there. So there was a mark essentially allocated for having correct variables and correct numbers. Okay. Hungarian algorithm. This one was done exceptionally well. Students seem to be having, I think the last couple of years, the questions on Hungarian algorithm have been done very, very well. So starting with just pulling information out of the table essentially. So we're looking at 73, it's shaded there for them, and we're just looking to see what does that mean. It's to do with Jacob and diagnosing wiring issues. So you can see we've got various different units of time, and they just obviously had to pick the one that was correct there. Calculate the number of hours training that Benji had. So all we did there was we were just adding across to find Benji's total. Obviously units in hours here. The next one asks us about 4 apprentices will be working on a major company project where the 4 tasks need to be completed at the same time. So at the same time is quite important here in the context. For each task, the project manager wishes to allocate the apprentice with the most hours of training. State why this is not possible. Okay, so we look at what we have here. Kelly actually has the most hours for every one of those tasks, so it isn't possible. And that was really the only answer that we could take with this question. We then go on to look at the Hungarian algorithm process itself. So we've given the original array, we've performed the first step. It's a maximization problem, so we're just asking what has actually happened in this case. And essentially, the 95, which was the largest value, every other value we've done 95 minus that value. So anything along the lines of we've been doing a subtraction around that value. Okay. Next thing is looking at the completion of the Hungarian algorithm. I've shown the solution here for, I'm just going to go in a bit on that. I've shown the solution here for rows first, so completing rows first. We do have, I think there's some teachers out there who actually teach doing columns first. You end up with the same solution. Essentially, you're subtracting your rows, you're subtracting your columns, and you get into a stage where you're not covering the correct number of lines. So we're then looking at, I've highlighted in green where we're covering the lines. The red squares, they can either do the line pattern this way or this way. The bits that are shaded in black, we obviously add one onto, and we take one away from the ones that are in red. And that gives us either this array or it gives us this possible array. And it hasn't asked for it in this section of the question, but I've tried to show the options for the various jobs. So the ones that are in yellow are essentially fixed, and the ones that are in green and purple, don't know if you can quite, yeah, green and purple, they can obviously switch around. So you've got the same allocation either way that you do it. And I'm pretty sure if you'd done it the other way and done columns first, it was the same number of steps that were involved. So students weren't penalised if they did it one way or the other way. We did come across a rather different method. Got that in there. We'll chuck it on. Might as well. This was a rather different method that we saw, but it wasn't actually performing the Hungarian algorithm. So we decided that because it wasn't performing all steps in the Hungarian algorithm, that we wouldn't award it the full credit. Sorry, can you hear me okay? So we decided with something like this. We saw it a couple of times actually, which is why we highlighted it. But it wasn't, although it got to the correct answer, it wasn't actually performing the steps of the Hungarian algorithm as such. So we decided that it couldn't be awarded full marks. And essentially what's happened here is they've covered a 0 and then taken away the smallest value each time. They do get to the same solution as what we had with the version that I've just shown before, but we're looking to discourage using that method.
I quite agree with that one. That ultimate solution, did they get some marks?
Yeah, they could get if they produced. So that was a student's. That was what was actually presented by a student. That exact solution there, and we gave them 3 out of 4 for it. So we deducted 1 mark because it didn't actually follow the correct process for Hungarian algorithm.
Yes.
Okay. Right. Next thing was looking at the allocation. So the allocation was a little bit annoying because you had to switch between the pages with this. Unfortunately, it wasn't possible to get everything on the 2 pages. But essentially the allocation, as we talked about previously, Jacob and Sarah were in a fixed position, and Kelly and Benji moved. So there was a mark allocated for each of the solutions, and then they had to have 308 in both of the experience boxes. So that was obviously adding up hours of experience, and they both needed to be 308 there to get that mark. If they'd made a mistake, I think if they'd made a mistake with one of the allocations, but had 308 once, I think we gave them 2 out of 3 because they'd actually shown that they could do that process. Okay.
It's one of those moments where you've got to kind of teach the students, if we're saying to you that there's 2 solutions, they should know that there is 2 solutions in the previous answer. So if they don't have it, to try and teach them to go back and look through what they've done to see if they can get to the point of 2 solutions. So it's that teaching moment in class where you go, you know what? If there is and you don't have it, go back because you know you've done something wrong.
Last section here is just looking at a limitation in context. So there's lots of different limitations here, but I've just given 3 examples. So they can't work in pairs or larger groups, where, if you remember, we said earlier on that they must be completed at the same time, so they can't work together. Personal preference can't be taken into consideration. Some tasks might take longer or less time than others to complete. There's lots more limitations that we could consider. But obviously I'm just giving you a small selection of what is possible as an answer there.
Yeah, I think when dealing with assumptions and limitations, always try to get the kids to think of the context and try and put the context into things. Because when they become too generic, I think that's when we find they're losing marks. So if you can get the kids to sort of think about the questions about a gardener or the questions about a cleaning jobs and try to include that in their responses, they were more successful.
Yep. Does anybody else want to ask anything there? Okay. So I think that question was out of 12 marks, and I think about 80-odd%. I can't remember the exact numbers. It's in the subject advice, but I think about 80-odd% were getting 10 marks or more for that question, so it was really very well done. Okay, question 6. What I'm going to say about question 6, it's 18 marks, but essentially it's 3 different questions within one bigger question, okay? So each of the pages here could be worked on independently, and it's really only that last section where things are kind of tied together. So we look at what we've got in this first part. We've got a simple home loan calculation where we're looking to, again, do that, show that. So setup of the calculations, what we're looking for. Again, common places students will make mistakes, really putting the PV and the FV the wrong way around, or having an incorrect PY/CY value. So it says approximately 2,100. The answer the calculator will give you is 210402. If you follow on through with the 2100, then markers will follow through with that, okay? So you can follow with the calculated value. Obviously, if you couldn't do that, you could still use that 2100 there as well.
Yeah, to add to that, for them to get their full marks in that question, they actually have to show the answer 2104.02, and that's because we've told them that show that it's approximately 2,100. So if they just give us those calculator entries, we don't know that they know how to put them in the calculator and get that answer. So in a show question, you need to be telling the kids, you actually have to write whatever your calculator is giving you to get those 2 marks.
Can they reverse engineer that one? I think last year that they were allowed to submit, even though that's not how it's teach it, but where they put in the repayment.
Yes, correct. And that's with all finance questions. They can reverse them. So what they would be doing is they'd be putting the payment as 2,100 and they'd be proving that the PV is actually approximately 356,000, and that's our problem.
Or they could do the N was approximately 300 as well. So there's various different ways they can do that.
Either way, they need to give us that final answer of what they're getting on the calculator.
Yeah. Next question is asking about the interest. So the easiest way of doing this is using the amortization function on the graphics calculator, where you've got PM1 is 1, PM2 is 300, sum of interest 275, 205, 94. You could also do PMT times N minus PV. So either of those 2 methods works. If you look at the space that's been allocated here, we're really looking for students to use that amortization method. It makes quite a lot of the questions actually more straightforward for them. State 2 reasons why your solution to Part A would be considered unreasonable. So it's likely interest rates are going to change. Grace may employ interest minimization strategies. Personal circumstances may change, so she might borrow more money, she might move house. Lots of different things on there. What I want to just highlight here is if students gave us 2 different interest minimization strategies, then because it's technically part of the same answer, then they couldn't get 2 marks for giving 2 interest minimization strategies here. Do you want to add anything there? No. Any questions there? Okay. Last section here, Part B, show that the remaining balance on the loan after 3 years is approximately 333,000. So again, you could set up another question, something similar to what you've got there, or you can go to the amortization function and you can actually work out the balance. This time PM1's 1, PM2's 36, and it gives you the 333,173.60. Again, as we said earlier, the cents, not quite as important there. Obviously, if you'd use the 2100, you'll get a different answer there. It'll be close, but it'll be slightly different. So the next part of the question goes on to the offset. And this is where we started seeing students kind of go, oh, offset, we don't like that. And we saw lots of blank spaces. But if we break it down, it's really only the third part of Part C that is challenging or more challenging. All they're doing with this first section is basically taking 50,000 off whatever answer they had for the previous section. If they'd done 50,000, or so if they'd done 333,000 minus 50,000, they got a mark for that. So that wasn't particularly difficult. We're then looking at using that value and doing a loan, finding the future value after 4 years. Again, not really that difficult. It's similar to what they did in the first part of the question, but obviously we're looking at, can they pull out the correct bits of information from the question in order to do that calculation there. I would say that both of these sections were actually done relatively well. Do you agree with that? Yeah. So these sections were done pretty well. And as I said at the beginning, they could have come to this page, used that answer there and this answer here, and it will allow them access to that part of the question. So even if they couldn't do some of the bits earlier on, they can still get back into the question on that second page. Okay. This was not done very well at all. I think that's fair to say. What we're looking to do is calculate the interest that was saved over the duration, having that 50,000 in there for 4 years. And the key wording in here is over the duration of the loan, okay? So I've given 2 different methods here. The one on the left-hand side is looking at obviously adding that 50,000 back to the final balance you had here and calculating your end value. So how long it's going to take to actually repay the loan. We then have to work out, well, how long has the loan actually been going for? So we've had the initial 3 years, then the 4 years of the offset, and then we had this 202.9 or 203 months essentially. If you look at the time that the original loan would go for was 300 months, we've now got it actually only going over 286.9. We multiply that by your PMT value, and that gets you your interest saved.
10 minutes.
Okay. Oh, it should be fine. The other way to do it is in Part A, we calculated your sum of interest. So that was the sum of interest for the entire loan. You could have done a sum of interest calculation for that first 3 years. So students who are using the amortization, we would encourage them to actually do a sum of interest calculation, maybe put it on their scrap bit of paper and just record that information, and then they can actually put that in that final section if they're going to use that method. If you've got all the information in your calculator anyway, you might as well do the calculation. It only takes 10 seconds. You've got the next 4 years, so working that out for the 4 years, and then you're working out how long, obviously you've got to do that end calculation the same as what we did over on this side. The difference here is with your end value, you can't put into amortization a decimal value, so you do have to round that up to 203, but it will give you a sum of interest for that section. And then it's just this value there minus all of the interest from each of the various sections. And you can see it's not exactly the same solution, but that's due to the slight difference in the 203 as opposed to the 202.9 that we had previously. So we're more interested in the method that the students have gone. Do they understand what they actually have to do in order to calculate that? I think yes.
So they're allowed to round up those months to 203, and it's just the follow